Okay, today we are going to continue with the esterification. Please give a heading. Esterification. Okay, so a few more examples from esterification. And look at this. If I ask you that straightforwardly, you have to make an ester. Okay, now can you please react these two compounds to make an ester? Draw the structure of the ester when these compounds formed. H2SO4 is used as a catalyst. Please write the names of all these things, okay? I'm giving you 2 minutes. Please do it. Are you done? Please write the name of ester and the name of the reactants as well. Are you done? Okay, we know what happens. The carboxylic acid, the first thing I have to identify the functional group present in these compounds. The first thing is carboxylic acid. So carboxylic acid is the one in the first. And what will be the name of carboxylic acid? Propanoic acid. And the alcohol is going to lose its what? H. The second compound is alcohol. What is the name of alcohol? Ethanol. Right? And now they are going to combine. I always tell you to write the carboxylic acid first. So I copied the carboxylic acid here. And what about this? And then this OH is gone, this H is gone. So what is left? Then yes, next is O. And how many oxygen with this alcohol? Oh, how many carbons? Sorry, 2 carbons. So here is the carbon, and here is the carbon. Plus H2. So this is the ester form. What is the name of the ester? Can you please tell me? Do you derive the name from these two? This is aryl and this is OH. So what will be the name then?
Ethyl propanoate.
Yes, well done. Ethyl propanoate. Okay, now I'm going to ask you the other way around. You have to make me, please pay attention, an ester methyl methanoate. An ester methyl methanoate. Okay, please give it a shot. First, draw the structure of methyl methanoate. Please draw the structure of methyl methanoate.
सर वो ऊपर वाला कौन सा है?
Ethyl propanoate. You have to make an ester on the methyl methanoate. Once you are done making ester, then I'll go to the next part, the next question which I'm asking you. Methyl methanoate. Anyone done? So from methanoate, I got to know okay, which carboxylic acid I have to make.
Methanoic acid.
Right, COOH, HCOOH. This is methanoic acid. From methyl, I got to know which alcohol I have to make. One carbon alcohol, right? So methanoate, so methanoic acid. So just take the OH off because in esters, carboxylic acid don't have OH. Okay, and then methyl, mean an alcohol with one carbon. So this is O and then one carbon. So I write it here. So this is methyl methanoate. Now the next question is, can you write a full equation for the formation of methyl methanoate? So which two things you need to make this compound? Two things, I mean carboxylic acid and which carboxylic acid? Methanoic acid like this. And which alcohol? And they combine to give what? Okay. So this is methanoic acid. This is methanol. And this is methyl methanoate. And sulfuric acid is the catalyst. Okay. Now the next one which you have to make, please pay attention, that is propyl ethanoate. First draw the structure of ester, then write the equation for the formation of this ester. Next is ethyl butanoate. The next one is propyl ethanoate.
और उस प्रोपाइल इथेनॉल में उसमें
इसके दो
प्रोपेनॉल एसिड होगा और प्रोपेनॉल होगा प्रोपेनॉइक
बना के स्ट्रक्चर बनाए, पहले एस्टर का स्ट्रक्चर बनाए. Propyl ethanoate. Propyl ethanoate. The last one is propyl ethanoate. No, sorry. That is ethyl ethanoate. Okay, I'm going to draw the structure of propyl ethanoate. So ethanoate means ethanoic acid. So first I write ethanoic acid. And I know in ester, the ethanoic acid's OH should be missing. So I just took off this. Ye wali cheez. Okay, so I'm going to erase it. And propyl mean how many carbons in alcohol? 3. And this CO has a oxygen of the alcohol. And then how many carbon with this? 1, 2, 3. And we know the rules that every carbon should have how many bonds? Like this, plus what? H2O. And on the other hand, what are the reactants then? What are the reactants? Ethanoic acid. And then what is the other reactant? Propanol. Here it is. Got it? Ethyl butanoate. Anybody did? How? Look at this. Butanoate mean how many carboxylic acids? How many carbons in the carboxylic acids? Is this the butanoate? So what in ester, what I have to remove? OH? And what is the next? 2 carbons. Just ethyl mean put oxygen of alcohol and put 2 carbon. That's straightforward. And every carbon has to make how many bonds? 4. So fill the hydrogens accordingly. Okay. Next. What will be the reactants then? What will be the reactants? Butanoic acid, 1, 2, 3, 4. This one plus ethanol, OH. Ethyl ethanoate. So this one is butanoic acid. And this one is what? Ethanol. Okay, ethyl ethanoate. Ethyl ethanoate, बच्चों. Ethyl ethanoate. Anyone did? Done? Okay, ethyl ethanoate mean ethanoic acid. I have to remove what? OH. And then oxygen of alcohol. How many carbons with that? Ethyl mean 2 carbon. Plus H2O. And what are the carboxylic acid and alcohol? Ethanoic acid, and what is other? Ethanol. Okay, so this is ethanoic acid, and this is what? Ethanol. Okay, so this is ethyl ethanol. So this is how you make the esters. So please write down. Esters are fruity smelling liquids. Fruity smelling liquids. They are used as a solvents. फ्रूटी FRUITY जैसे इथाइल एथेनोएट पाइनएप्पल जैसा होता है प्रोपाइल एथेनोएट एप्पल जैसा होता है so they give some kind of flavors the fruity flavors okay they are used as a solvent they are fruity smelling liquids they are used as a solvent they are also used as a flavoring agents
सर ऊपर करें
Okay, let's continue with other reactions of carboxylic acid. This was the one of the reactions of carboxylic acid known as esterification. Let's continue with other reactions of carboxylic acids. Okay, the other reactions of carboxylic acids are reaction with, write down please, reaction of
बस
carboxylic
स्क्रीनशॉट
acid.
लेना है
Okay, done.
यस
Reactions of carboxylic acids with metal and metal compounds. For example, look, if I take an acid, please pay attention. What is this acid? It is methanoic acid. I can also write it like this. If this is ethanoic acid, I can also write it like this. Okay? When metal reacts, for example, when Na reacts, they only displace, what I'm using word displace, take the place of the hydrogen of carboxylic acid that is at the end, wo jo OH wala hai. Right? For example, if Na reacts with HCOOH, it's going to displace this last hydrogen, COO ke baad jo hota hai, right? And as a result, it will be like this. HCOO, O is there, and then because of the loss of this hydrogen, they get one negative charge. And if the acid is known as methanoic acid, what is the acid name? Methanoic acid, this ion that is formed due to the loss of hydrogen is known as methanoate. We know, we just did it, investors. This is known as methanoate. And instead of that hydrogen, now sodium comes here. And sodium has one positive charge. Sodium is a metal belonging to group 1, so it has a charge 1 positive. 1 negative, 1 positive cancel each other. So therefore, we write it like this. HCOO and then Na, and we call it a salt, sodium methanoate. And the hydrogen that has been lost, that is lost in the form of hydrogen gas, H2, not H alone, right? So this is H2, and then we can balance it, for example, H2 gas, and we can balance it by multiplying 2 here, 2 and 2 here, right? So when methanoic acid reacts with sodium metal, a sodium methanoate, which is a salt. And what is the other form? Hydrogen gas. So this is what I was trying to say, that how this acids react with a metal to form a salt, right? And the salt name is sodium methanoate, right? So please write it. Similarly, if this is ethanoic acid, 1 minute, I'll give you the time. Please pay attention. 1 minute. If this is ethanoic acid, I reacted with sodium metal. Sodium is going to come and displace which part of the acid? The last hydrogen. And the product is going to be CH3COO negative. Which ion? Methanoate ion. And then Na positive. So what is this? CH3COO Na. So what will be the salt name? Sodium ethanoate. And along with the other product, the hydrogen gas. For the balancing, you have to multiply it with 2, 2, 2 with everyone. Okay, now copy this. So 9 to 11, 10, 11. Ten, 11, 10, 8, 9, 16, 17, 17, 16, 17. Done? Next. Should I write? Okay, next. Pay attention. Pay attention. If I take a salt, carboxylic acid, CH3COOH, and I ask you to react with magnesium metal, can you write the products, please? Magnesium is going to come and displace hydrogen, the last one. What will be the formula of the salt and what will be the byproduct? So CH3COO and then Mg. But you know, magnesium is in group 2, so it's not going to have +1 charge. It is going to have +2 charge. But the ethanoate still has -1 charge. And we learned this in formula writing chapter, that when they don't cross, when they don't cancel the charges, then you have to what? You have to multiply, cross multiply. So the formula of the salt, which is magnesium ethanoate, is like this: CH3COO whole twice and then Mg. Plus obviously the hydrogen gas that given off is H2. So ethanoic acid reacts with Mg metal, and the salt form is magnesium ethanoate. Okay. Now the same principle goes ahead of it. And now if I have the metal compound, the metal compounds are those: metal oxide, metal hydroxide, metal carbonate. The same formula, the same principle goes with everyone. For example, look at this. If I have CH3COOH and I react it with sodium hydroxide, even then we know the principle. The sodium is going to displace what? Hydrogen. So the one of the product is CH3COO, sodium ethanoate. But the other product now, the H and OH, they are going to combine to give what? Not hydrogen gas. They are going to combine to form water. HOH, the water. Okay. So in this case, when ethanoic acid reacted with a metal hydroxide, sodium hydroxide, not the metal alone, then one product is sodium ethanoate and other product is water, not hydrogen gas. Okay. Similarly, if I take ethanoic acid and react with metal oxide, metal oxides are solid. Now what happens? Don't bother about the number of moles of Na. Okay, they'll be balanced later on. At this moment, you just think of one metal going and taking the place of hydrogen. So what will be the product? CH3COO Na plus H2O. Okay, so 2 multiplied here, 2 multiplied here. Okay, because this is one negative cancels one positive. Okay, so the salt is sodium ethanoate. Similarly, if I take CH3COOH and react it with a metal carbonate like CaCO3, that is also a solid. All acids are always aqueous in their physical state, and the other compounds, I'm also writing their physical states now. Okay, now what about this? Again, don't bother with the number of moles of sodium. The rule is that sodium is going to go and take the place of hydrogen. So one product is again, not always, again CH3COO Na, sodium ethanoate. But now additional thing, along with the water formed is what? Whenever there is a carbonate, keep in mind CO3, yes, the carbon dioxide gas. And carbon dioxide, whenever it is formed with effervescence, fizzing. This is also a test of carboxylic acid. Adding carbonate into a liquid fizzes, so it means this is a carboxylic acid. Okay, I'll explain in the next part. And last but not the least, when CH3COOH reacts with sodium hydrogen carbonate, instead of carbonate, it's a hydrogen carbonate. The principle remains the same. And what is the principle? It's going to displace hydrogen. So COONA, sodium ethanoate, along with water and the fizzing means carbon dioxide with effervescence.
तो आपने कार्बन डाइऑक्साइड के नीचे क्या लिखा है?
Gas and effervescence. Effervescence is the fizzing. In order to balance two. So this is how the metal compounds, when react with acids, they always produce salt, water, and carbon dioxide, salt and water, or salt and hydrogen gas. And when the reaction is fast, they also fizz. They also produce a lot of effervescence. So please write down the last two reactions. Last two reactions are also the test for the functional group of carboxylic acids, right? So please write down, adding carbonates or hydrogen carbonates if produces effervescence or fizzing, indicates the presence of carboxylic acid functional group. Okay. And now this is a homework. Please, you have to complete these equations. Please complete these equations. Products of these equations, okay? Sometime when the product is written, you have to write the reactant. When the reactant is written, you have to write the product. जी. Okay, but so you have to write the name and complete the equations and balance these equations. Okay, so please mind this, that you have to write the names of all those as well. Okay, so you have to complete these equations: 1, 2, 3, 4, 5, 6, 7. These 7 equations, you have to complete them. With this, we have come to end of carboxylic acid. Next, we are left with the polymerization in organic. Friday, we are going to have the complete organic test. Okay, this Friday. 13th. Okay. Allah Hafiz.